quite a fun idea. Obviously, so the plan for this evening is that we're going to show you some of the objects in the night sky that we get to see down here that you unfortunately physically cannot see. And we've got some absolute beauties here. We've got three of the brightest globular clusters in the sky down here. We've got some beautiful open clusters, things like the Eta Nebula, which I don't think ever shows its face at all up where you are, unfortunately. So we're probably going to look at, obviously depending on how things go, sort of aiming to look at 6 or 8 different objects this evening, and we'll chat about them. In terms of what I'm going to be using, I'll show you a couple of pictures now once I've remembered how to do screen sharing and all of that. So please excuse in advance any technical bugs. I'm a bit of a technophobe in that regard. So just to give you an idea of what I've got set up here. So I'm in a place called Nelspruit, which, if any of you know South Africa, it's basically the largest city close to the Kruger National Park. But when I say city, I mean it's what you guys would consider a town rather than a city. So even though I'm in the suburbs here, but I'm still under sort of Bortle class 5 skies. So it's still pretty good, even though I'm only 6 or 7 minute drive from the city centre. And then, yeah, in terms of sort of where that is, to give you an idea geographically, I'll show you on the map in a second, but just south of the Tropic of Capricorn, basically. The Tropic of Capricorn itself runs through Kruger Park about 200 kilometers north of where I'm sitting at the moment, 150 kilometers perhaps. I was actually very close there this morning. I just got back this morning from doing some astronomy training for some of the guides in one of the lodges in Kruger Park. So I've just spent 3 nights in the bush, went on a game drive last night and saw a buffalo, elephant, and amazingly 2 different leopards, which was pretty amazing, right next to the vehicle. Beautiful animal. Yeah, so I was doing stargazing training up there. And just to give you a sort of very brief background about what I do and what Celestial Events is, it was sort of born out of my history, my career history out here in South Africa. Originally, I was born in England, but I've been over here for about 15 years now, working as a safari guide, as you guys would call it, out in the bush. I've done guiding, and also then I did a few years of training. And from that, I felt that the guiding or the guide's knowledge of the stars out here, which is such an integral part of the safari experience because of the ambience that we've already joked about. I mean, we were literally doing stargazing last night, listening to lions roaring in the background and spotlighting an elephant that walked past the deck we were standing on. So I mean, it's an amazing experience. So I really felt it was time to educate the industry a little bit better, to make something more of this amazing opportunity with the dark skies over game reserves. And yeah, we've over the last couple of years we've introduced a new qualification that field guides can do now for stargazing. And yeah, I've got a company that does stargazing events for guests, training for guides, and for anybody else who wants to learn more, and also some sort of basic astrophotography stuff as well. And in terms of equipment, I've got a 10-inch Meade LX200 Smith Cassegrain telescope here. So in terms of focal length, we're looking at about 2,500 millimeters, which is quite a lot when you're actually doing photography, which you want a more of a wider field of view. So I've got a 6.3 focal reducer attached to it as well, just to sort of back that off a little bit. And then I would love to say that I've got wonderful equatorial mounts for astrophotography and CCD cameras, but unfortunately we're not quite there yet. The business is only growing. So I've got a Nikon D7000, which unfortunately does have a crop sensor, but with the focal reducer, that sort of cancels it out. And I've just got it hooked up to the computer, so I'm sitting outside next to the telescope, and we'll slew to different targets, and I'll take sort of 30-second exposures, and then we'll run them through Photoshop just for like 60 seconds perhaps, and just do a bit of a stretch on the light and see what we can see. But that's far too much of me just talking. So let me show you exactly where I am. Have I got shared screen privileges?
Yeah, you should be able to, Ben. Thanks for that introduction. That was great.
And Ben, just to keep me from looking at the map, Kruger Park's on the border with Mozambique. Am I in the right spot?
Yes, that's right. It's sort of that triangle between Mozambique, Zimbabwe, and South Africa. I did have it open on Google Earth here. How do I zoom out again? I think. Sorry, I think your faces are all in the way of my buttons, are you? So, yeah. Okay, so that's where I am at the moment. Mbombela, which you can see here, is sort of the new name for Nelspruit, which is considered the gateway to Kruger Park. If we just zoom out a touch. Sorry, a little bit slowly. You can see here this sort of more open patch of land. This is Kruger Park now. And there's the country boundary for Mozambique that you just mentioned along here. So Kruger Park runs about 400 kilometers north-south and about 100 kilometers at its widest point. And so as we say, we call it the gateway to Kruger Park. And I was up here this morning. No, sorry, up here, close to Hoodspray. The Tropic of Capricorn is around about here, just to give you an idea. So that's where I am broadcasting from this evening. Hopefully there won't be any lions or leopards where I am this evening, otherwise I may be in a bit of trouble.
Add some excitement.
Yeah, I just want to show you my telescope so you can just see what she looks like. Can you still see this screen?
I can.
Yep. Okay. So there it is, set up on for a night. So Smith-Catty Grain telescope.
Oh no, we can't see the telescope. We're still looking at the map, Ben.
Ah, okay. Hold on.
Yeah.
Okay. Now you should be able to see it.
Yes, there it is.
Yeah. Okay, so Smith-Catty Grain telescopes. So if anyone's not aware of what that means, it basically means we've got what we call a corrector place at the front. The light comes in, hits a mirror at the back, and then is bounced back up again to a secondary mirror, which you can actually see on the front of the lens, and then it bounces back down into the eyepiece. So we bounce the light 3 times, which enables us to get a very long focal length from a relatively short barrel. And as you can see, just an alt-azimuth mount. Unfortunately, I'm in the process of negotiating to get an equatorial mount. It's mine if and when I want it. I just need to make a plan to go and get it, which will obviously be far better in terms of longer exposures. But for 30 seconds or so, for what we're doing this evening, it should be fine, he says, hopefully. Right, let's just show you what we are going to be looking at. So can you guys see Stellarium now?
We can.
Yep. Okay, great. Okay, so I'm pretty much sitting here. My telescope at the moment is hopefully pointing to this, the Jewel Box, which is a very famous open cluster down here in the Southern Hemisphere associated with the constellation of Crooks, or more commonly known as the Southern Cross. And culturally, that's a very important constellation for the Southern Hemisphere, because in many places like Australia and New Zealand, it never even sets below the horizon at any point during the year, and that's why it's on their flags. It's on the flag of New Zealand, Australia, Brazil, various ones of those specific islands. So culturally very important, and very important for us here, because for you guys up in the Northern Hemisphere, of course, it's easy for you to align your telescopes and things to celestial north, because you just pointed at Polaris. We do not have a South Star down here, so we have to use the Southern Cross to help us find celestial south, which is a little bit more, let's just say, of a mission. It takes a little bit longer. Celestial south is somewhere down here, very close to Octans. Sigma Octans is sort of the closest star, which you need a pair of binoculars to even find. But to find south, we draw a line through the Southern Cross, and then we take the two, what we call the pointer stars here, Alpha Centauri and Beta Centauri in Centaurus. And we take the midpoint of these two stars and draw a line perpendicular. And where that line crosses the line of the Southern Cross, so somewhere around about here, is celestial south. And unfortunately, that's the best way we can do it. It's a pretty accurate way of doing it. But so the polar alignment scope and things I've got for the star tracker, they show you the little asterism in Sigma Octans. You have to line up the 4 stars in the 4 circles, and it's painstaking work at times. But let me show you what we're going to look at first. And of course, Samuel, please jump in at any point, and anyone jump in at any point with any questions. And Samuel, welcome to help me fill in the blanks whilst we're looking at things.
Sure.
Okay, so we're going to go for the Jewel Box here. So it's very, very close to the Southern Cross. You can actually see another famous area of sky, which unfortunately I can't really show you, but it's called the Colsack. So this is an absorption nebula, or a dark nebula. So just a very thick area of dust and gas. And right next to it here is the Jewel Box, which is what we're going to have a look at now. Just interestingly, this is a very nice double star Alpha Crucis, easy to resolve in a telescope as well. In terms of how far away this is, we work on the basis of, I think it's around about 6,500 light years away, but because it's associated with this dark nebula and all the other gases there, it's hard to be absolutely sure, but we assume it is. So it's very, very small in the sky. You can just pick it out with the naked eye. And through binoculars, you can make it out as a very, very small cluster, but it's a beautiful telescopic object, and as the name would suggest. So if you'll bear with me 2 seconds, I'm just going to try and snap the picture and pop it into Photoshop quickly, and I'll be back with you in about 1 minute.
Sounds good. Thanks so much, Ben. So
Certainly have to make the obvious comment, which I know Ben will appreciate, but it's so weird to look up the sky, in real time like that and not recognize it.
Well, yeah, it took me a while here as well. Obviously, growing up in England, I learned the sky the other way around. So for me, it took a little while, certainly, to get my head wrapped around everything being upside down. But yeah, when I go back to the Northern Hemisphere now, I'm equally confused. Right. Okay, so just to give you an idea, it's taking the photo at the moment. So as I said, it's just unfortunately, it's not astro modified or anything. It's a bog standard DSLR camera. I was using it on my Safari yesterday. But settings wise, I've obviously pumped up the ISO. We're not going for sort of website quality images here. So I've got my ISO up quite high at 4,000, and I'm taking a 25-second exposure.
So as Ben was mentioning earlier, the name of this object, the jewel box, is named after how it appears. I think it was actually Herschel that said the following about it. This cluster, neither a large one or a rich one, as yet an extremely brilliant and beautiful object when viewed through an instrument of sufficient aperture to show distinctly the very different color of its constituent stars, which give it the effect of a superb piece of fancy jewelry. That's the name, the jewel box.
Hopefully you'll be able to see that in a moment. There's a lovely feature right in the center of a line of 3 stars, which we call the traffic lights, because we've got one very obvious orange star there, and then a more orangey yellow one in the middle, and then a bluey greeny one at the back. And it's quite obvious when you see it. So I'm just taking another photo because the first one came out a bit blurry as if something had moved.
That'll happen.
Yeah, nudged something. Seems I've got a little bit more rotation than earlier, but it's very high in the sky at the moment for us here. Let me just slightly shorter exposure. Sorry for the delay.
No worries. Just building up the suspense.
Yeah, well, nothing ever goes smoothly when you want it to.
No.
It's typical because I came out earlier and took some test shots and they were fine. So I'll use one of those otherwise.
Sounds good. I mean, for all we know, you could just be in a bathroom with the lights off, right?
If it's any consolation, I assure you I'm not. A bit of movement. Okay, sorry guys. I'm just going to show you one I took before we went live. It's got a bit of movement for some reason. 10 seconds.
Cue the Jeopardy music any moment.
Right. Okay. So we're in Photoshop now. So here is the jewel box. Let me just zoom in slightly. Okay, but there we go. So hopefully you can see that we've got some lovely colored stars. Sorry, the focus is a little bit off, but you can clearly see this nice red giant star. In fact, I think it's actually a red supergiant. And this lovely line, we haven't quite picked up the colors, but this is very much more of a yellowy star, and this has a lot more of a greenish tinge to it. So this is what we call lovingly call the traffic lights. Let me just see if I can bring out a little bit more detail on that. Sort of deathly silent. I feel under pressure now.
No, it's good. It's funny when I first look at that object, it almost reminds me of the constellation Orion, just with the orientation of the stars, particularly the 3 belt stars in the center and bright one on top and on the bottom.
Yeah, definitely. It has that. It does look like a sort of a mini Orion's belt, certainly.
Yeah.
But yeah, we haven't quite picked up the color I was hoping to there. But you can see over here, certainly you can see all these reddish stars here, which are red because of we're sort of infringing on the edges of the Colsack now. So only those longer wavelengths of light are coming through. So it's very difficult to know for sure the true nature of these without doing proper examinations on it. But when you look at it through the telescope, you'll find a lot of these stars have that reddish hue to it. I'm going to have to consult my notes as to exactly the specifics on each of the objects. My apologies, I can't remember everything off the top of my head.
Okay.
I did do some planning.
While you're looking at that, I just wanted to comment on the two different reasons behind the color that we're seeing in the stars, which I think is really interesting. So you mentioned the red supergiant. So that star is intrinsically a reddish color on the red end of the color spectrum because it's cooling off, presumably starting to burn helium or even heavier elements in its core before it begins its way to becoming a supernova when it explodes. Whereas the stars on the right-hand side of the frame, you mentioned are reddish because they're being obscured by dust. And it's the red wavelengths of light from those stars that are actually making it through the dust, whereas the shorter wavelengths get blocked. So those stars might actually have a whitish appearance or bluish appearance, but there's no way to know unless we do some color correction and know their distance.
Yeah, exactly. But that is I was trying to find if earlier any statistics about that star, because one of the cool things about the jewel box is it's very, very young in terms of open clusters. I mean, yes, all open clusters are young by definition, but this one, some sources have even dated it as young, in inverted commas, obviously astronomically speaking, as young as 7 million years only. The more accepted figure is 14, but some people have suggested as little as 7. So for such a star to already be in that stage of its life after potentially over 7 million years, it must have been one hell of a big star when it started out, that's for sure.
Yeah.
And I
think, definitely.
I found
like Betelgeuse.
Yeah. I found I think the brightest member, which I think is the one there on the sort of the top right, is they say about 85,000 times as bright as our sun. But obviously, with all these being very young stars, they'll all be very bright and vibrant. And I think I'm right in saying, maybe Sammy, you can help me out here, but when you do read figures like that, that is the sort of the combined spectrum they're talking about, isn't it, rather than just the visual magnitude?
Yeah, I think it's usually like I'm forgetting the name of the two filters that are usually used to subtract from one another, or the magnitude, but not the whole spectrum actually, but the difference between two different filters.
Yeah, so lots of nice energetic young stars, which it's one of the youngest star clusters known, certainly. But so through a telescope, it's really beautiful, and it's one out here that everybody knows. It's kind of strangely in the guiding community. It's obviously where I work. There is within the standard guiding qualification, there is a little bit of astronomy that's expected, and that's one of the objects you're expected to point out. And I always wondered why, because most lodges don't have access to a telescope, and to be honest, through binoculars, it's just a little tiny grouping of stars. You can't see very much. I think probably because of its proximity to the Southern Cross and the importance of that in terms of navigation. But through a telescope, it really is rather spectacular. You certainly can see those colors a little bit better. And you're quite right, it was Herschel who described it as a casket of variously colored precious stones, rather fittingly.
Very nice. I like that one.
All right. Okay, I did have a sort of a list of the order of which I wanted to go to things. So you caught me a little bit unawares. Just Murphy's Law, as we say over here. Just as I was getting ready, I bumped the telescope and had to realign it, which is why I disappeared and was a little bit late. So everything's all a little bit up in the air because everything goes wrong at the last minute, but we make it work. Right, here we go. Oh yeah, we've got to try another open cluster first. I think, to be honest, if I can say this, and no disrespect to open clusters, but open clusters, because they don't have a definite structure, yeah, they're pretty to look at, but I don't think there's a great deal that you can actually say about it. But the next one I want to show you is the Southern Pleiades, obviously because it's a nice direct parallel to your the Pleiades from the Northern Hemisphere, although we also do see that. And we find that very close to the Southern Cross. We've got various, let me just turn the deep sky objects off. We've got 3 crosses that we actually look at in the Southern Hemisphere from in this area of the sky. So this whole area we're getting into now is the old Argo Navis, the ship from Jason of the Argonauts, which was split in the 1700s by French astronomer de la Caille from his observatory down here in South Africa at the base of Table Mountain. And he actually also named Mensa, the constellation, after Table Mountain, interestingly. Yeah, so here's Vela the sail, Puppis the stern, and Carina the keel, and Pyxis the compass. But just here, you kind of make out this cross here, where you can imagine these lines continue here and here.
We're not seeing the map that you're...
Are you not seeing it?
No,
Oh, no, man. Sorry. Okay, is that better?
Yes.
Right, sorry, guys. Okay, so here's the sail, Vela, Puppis the stern, and Carina the keel, and you kind of imagine this as a big ship.
Oh, yeah.
Jason and the Argonauts ship. So that's the Argo Navis, which was split into these three individual constellations in the 1700s. And then Mensa, which is Table Mountain, is right next to the Large Magellanic Cloud. You can just see the Eta Carina Nebula there very obviously, but we're actually going to look at this area here. You can see this is the diamond cross that we call. So we go across there and down here. So we've got the Southern Cross, and we have a diamond cross, and then here we have the false cross, which is a very famous asterism, so named because mariners often used to get mixed up between these two. So to avoid that, they gave it the name the false cross. But we're going to look right here, this basically this star at the base of the diamond cross, which is known as the Southern Pleiades, and it actually looks just like a 5 of diamonds playing card, I think. But I'm going to just quickly go and align that. I will be back in 2 secs.
Sounds good.
And yeah, apologies for the screen sharing. I shall try and remember to do it more often.
Yeah, it's fine. So you said this one's nicknamed the Southern Pleiades. Is there a similar mythological story around it that you're aware of?
Actually, there's no mythology behind this one that I'm aware of. It was also discovered by the French astronomer de la Caille, as far as I know. But no, there's no mythology attached to it. You've got to remember, in terms of African mythology, there isn't actually that much available because so much of it wasn't written down. It was passed on orally, generation to generation. And so because of that, we don't have much to work with here. So, but there's very little mythology about the clusters or the deep sky objects here. It was so named. I know de la Caille did discover it. Whether or not he did actually name it as well, I'm not sure. But it was named because it does, allegedly, they say, bears a resemblance to M45, the Seven Sisters, the Pleiades. Personally, I don't see it. But that is what they say. Hopefully you can make up your own mind in a minute. Although I don't know if we'll get the whole thing in the field of view of the telescope. But I want to get the 5 of diamonds because that's a nice one.
Well, we just heard the telescope moving, so that's a good sign.
Yeah, the telescope has moved. Part 1 complete. Next problem is trying to get the camera to work. Yeah, so it's not quite as oiled as the other one that you guys use here.
Yeah, we've got a pretty sophisticated 20-inch scope that's got a permanent mount in a dome, and so that one has a 100-point alignment that was done when it was first set up. So it's pretty spot on right after you turn it on.
One day.
Yes, one day.
And gentlemen, the distance for the Southern Pleiades, how far are we?
It's also quite a way away. Actually, I didn't actually get it on there. Sorry, 1 second. I'm just looking at the picture.
Yeah, you do. Well, I'll leave
about 550 light years.
Oh, okay.
That's much closer.
Still in the local neighborhood. That's
Yeah.
about the same distance to Betelgeuse in the constellation Orion.
Right.
But all these open clusters are, as Ben was mentioning earlier, pretty young groups of stars that have just finished absorbing all the interstellar material that they've been made from, the nebulae that they were born out of. And so some of the open clusters, actually like the Pleiades, you can still see a little nebulosity around them, a little bit of fuzziness around the stars where there still is some diffuse gas that hasn't been absorbed by the stars. I'm not sure if that's the case with this open cluster, but eventually these open clusters disperse because of just the random motions of the stars. They move in different directions, and at some point, millions of years from now, won't be associated with each other in the same point in the sky. It's believed that the sun formed in a similar cluster of stars and has since migrated out of it. And we have no idea today which stars the sun actually formed next to. It's pretty difficult to figure that out at this point, but we think that it did form in an open cluster like the ones we're looking at.
Yeah, I'm unaware of any nebulosity associated with this one, unlike the Northern Hemisphere Pleiades, of course. But there's very little information on this one. It seems to be, they call it one of the big 5 objects of the South African sky. But there's very little sort of information on it. Okay, right, there we go. I've got some of it there.
And that's to match the big 5 megafauna, right?
Yeah, well, there's a big everything out here. Tourism has become a little bit ridiculous now. There's a big 5, a small 5, a baby 5, a big 5 trees, a big 5 birds. There's a big 5 everything nowadays. Right, I'm just going to share straight to the capture screen that I've got here. All right, so I haven't quite got it all in. It's only quite a small cluster in terms of. Can you see that?
We can, yeah.
Yeah, only a fairly small cluster, and it's fairly sparse in terms of it. But this is the little asterism, which is so nice. It does look just like a little 5 of diamonds. There is a couple more stars that are associated with it just out of frame, so it took a little bit longer. I just had to reframe to get the cross in. I rather like this one. But I think I'm right in saying there's only 74 stars associated with this cluster, so it's a very, very small cluster in that regard. But I just wanted to show you that one in, out of principle, because it's one that I thought maybe you guys have heard of if you've looked into the Southern Hemisphere, because a lot of people have heard of the Southern Pleiades. It's a very nice binocular target. But again, we've got too much magnification. I've got no night vision left. Bloody head torch. Sorry, guys. This is one of those evenings.
We've got the same issue with the Pleiades here. When you look at it through a telescope, or similar field of view with the camera, you see just this. You see a few bright stars, but it's not something that's eye-popping, as it is when you look at it with a pair of binoculars. When you actually get to see the entire cluster, and then it's quite lovely.
Yeah, definitely. I want to think. I'm going to go show you something a little bit more exciting now. So I think. It's one of those ones I'm toying with whether I should leave this one to the end, but I think it's so good that just in case there are some technical problems or it clouds over, I want to do it quickly. We have got, in terms of globular clusters, which I'm sure, so if you guys know, are one of the most beautiful objects in the sky. We're very lucky. We've got the 3 brightest in the entire skies down here. And we're going to have a look at the biggest and the brightest of them all, which is Omega Centurion, the constellation of Centaurus. Now, just to give you a little bit of background, because this is such a fascinating object, there are about 200 globular clusters known, and most of them are relatively similar, but this one is special because it is so much larger and so much brighter than all of the others. You can see it clearly in the naked eye, even from where I'm sitting. If I hadn't just blinded myself with the head torch, I could look up and find it. But I can still barely see you guys in the screen. I could look up and find it pretty easily with the naked eye. The way I used to find it is to draw a line through the 2 stars here in the Southern Cross, and it basically takes you straight to it. So in terms of numbers, most of the globular clusters, and feel free to jump in here, Samuel, but as I understand it, most of the globulars that you're looking at have got, a few tens of thousands, maybe a couple of 100,000 stars in it, if you're lucky. This one, on the other hand, has approximately 10 million stars in it. So it's got an enormous, enormous number of it. And even through binoculars, I always describe it as like a fuzzy golf ball. It's so obvious. And it even has its designation, the fact that it's called Omega Centauri. It was even catalogued by Bayer as a star, because it was of naked eye brightness, and it was only a little bit later they realized what it actually was. But by actually looking sort of deep into it, astronomers now are, I don't think there's any argument, because there's multiple multiple generations of stars in there, and just it has a strange motion, and it's moving at a different speed to other globular clusters. And it is now assumed that especially because there's multiple generations of stars in there, which you shouldn't get in a typical globular cluster, we think this is actually the core of a dwarf galaxy that was absorbed by the Milky Way somewhere in our past. And yeah, this is this sort of alien galactic core floating around about 16 or 17,000 light years away from us out in the halo of the galaxy. And I think there has even been I think I'm right in saying that there's been I know that's M4. They've found a planet in M4, but I know they've Captain Star, which of course you guys have probably heard of, being one of our closest stars, only about 12 light years away. It's pretty much assumed that it actually came from Omega Centauri, just based on its motion and its metal content, comparing it with these stars. And that has 2 confirmed planets, one of which is in the habitable zone of the star. So we're actually quite close to what is quite literally an alien star that was probably, or alien planet, sorry, which was one of the oldest planets we know of. I think it's about 11 billion years old, they estimate. So I think we should go there next, personally.
Yeah, let's do it.
Right, let me see if I can move the scope. So this is Caldwell 80. So for a lot of the Southern Hemisphere objects, we use what's called the Caldwell catalogue. Obviously in the northern skies, we've got the Messier catalogue, and we see a lot of the Messier objects down here, but see, Messier from France was unable to see this part of the sky. And then it was actually the British astronomer Patrick Moore, who created this catalogue of the southern skies, but because of Moore being with an M, he used his alternative name, apparently, which was Caldwell. So I think there's 106 Caldwell objects. So it's our equivalent of the Messier catalogue. Right.
But I don't know why I never thought of this. I'm not sure if Messier ever traveled to the southern hemisphere to do any observations of the southern sky. Are you aware of him doing that at all?
Not that I'm aware of. No, no records of it in any of the research that I've done. Most of the southern hemisphere stuff seems to have been done by the French guy de Lacaille in the 1700s. So from 1751 and 1752, he was based in his observatory very close to the base of Table Mountain, hence the constellation of Mensa. And amazingly, it still blows my mind that in the 1750s he was able to do this. He documented the positions of over 10,000 stars in less than 2 years. I mean, it's like 400 stars a night he would have had to have done to be able to do that. And there is a plaque on the headquarters of the SAO, the South African Astronomical Observatory. There's a plaque commemorating the great work that he did for astronomy. So a lot of these objects, Omega Centauri included, were discovered by him. And so he named a whole bunch of constellations down here as well, mostly after scientific instruments, very small ones, which we don't really use very much. Things like the fornax, the furnace, and then there's the clock and the compass and various other ones, but they're very faint to look at. Right, I think we've done pretty well here. For
Excellent.
a quick one, let me just share the screen with you. Where is it? Okay, so I don't know if you guys have seen photos of globular clusters up in the northern hemisphere, but this is an absolute monster. I mean, it's about something like the size of 3 full moons if you see all of it. I think I'd rather actually just open it in Photoshop and manipulate it there quickly. But you can just see how massive the thing is.
Yeah, that's beautiful. The closest thing we have in the northern hemisphere is the Hercules globular cluster, M13, which just started poking up over the eastern horizon in the last couple of weeks. But it's nothing like this. I think that.
I mean, this is a showstopper.
Stars. Yeah.
Yeah, we've got this one. We've got 47 Tucana as well, which is another beautiful, very, very dense cluster. But you can see how massive this one is. I don't actually think it needs much work to bring anything out, so I'm just going to blow it all out.
It looks pretty good to me.
Yeah, I'm quite happy with that for a quick. I mean, I've gone down to only 20-second exposures now, but it's such a bright object, it doesn't really matter.
So Ben was saying about the fact that Omega Centauri may be unique among globular clusters in that it may be the core of a dwarf galaxy that got absorbed by the Milky Way several million years ago. We also believe that the all globular clusters actually were independent from their host galaxies at some point, but were just basically large clusters of stars that then were gravitationally attracted by larger spiral galaxies. And the reason we believe that is another piece of evidence that Ben already mentioned, that these globular clusters don't occur in the disks of galaxies. They're all hanging out in the upper and lower halos of galaxies, spiral galaxies. So they don't follow the same orbital mechanics that most of the stars and spiral galaxies do. They seem to be captured objects. The Milky Way has actually captured several other dwarf galaxies that have been completely torn apart. But this seems to be the only one that we can actually still see the core of it remaining intact.
Yeah, as far as I said, it's still not perfectly focused, but I worry if I go and fiddle with it now, we might ruin everything. So I think I'm just going to leave it. But it's just amazing to think that there's 10 million stars packed into here. I mean, they say that the distance between some of these is as little as 0.1 light year. So sort of, you know,
Wow.
I mean, that's we're talking in AUs really rather than anything else. And of course, like anything else, I mean, I don't know if we really see it in here, but you might be able to pick up some blue. I'm sure there'll be some of those blue stragglers that you often associate with globular clusters, those young new stars, which you wouldn't expect to find in there. Just when two of those stars maybe careen into each other. But yeah, it is just a spectacular object to view. It kind of looks like a swarm of bees through the telescope, and it never fails to interest people. I'm sure, I don't know if you've got a Hubble image somewhere to show there, Samuel, otherwise I'll quickly get one.
You know, I actually have, just off to my left, I actually do have a printed Hubble image of the core of this. But yeah, if you want to bring one up, I was thinking just zooming in on this image that you have, I think would give us a pretty spectacular view.
We can try. I worry it may all sort of blur together, but yeah, I mean, you can see how much is there, but I think it's more of the principle that I've showed you it. But now let me show you a real photograph of it. Done. That's a big resolution one. I'm sure there's a faster way of doing this. Sorry, guys. Right, there you go. So should be a higher resolution photo of it. I don't seem to be able to zoom in on it. But yeah, that's from the European Space Agency, but perhaps gives you more of an idea of just the density of it. But yeah, just to try and fathom 10 million stars in one small area of space like that is it's pretty crazy. So I just realized I had the Caldwell catalog open as well, to just see what photos they've got of it. So it's Caldwell 80 is its designation. Yeah, maybe gives you a better idea of just the sheer density of it, and it's incredible.
That's the image that I've got on my wall just behind me. Yeah, all the old red stars in there, and I'm sure it's chocked full of planetary nebulas and little black holes and neutron stars and all sorts of other stellar corpses. Yeah, must be an amazing thing to think of, what if you were on a planet in there, to think what the sky must look like to you on a planet inside there. Must be amazing. Yeah, basically like being in a snow globe of stars.
That's a very nice description. Yeah. Right, what are we going to go to next? I think what we're going to try for next is we'll try the what we call the Keyhole Nebula in Eta Carina. Eta Carina obviously is a very famous area of the sky, not just the star, but that whole Eta Carina Nebula. So we're going to move our attention to here again, very easily visible with the naked eye. I can't show you the extent of the whole thing with the telescope just because of its sheer size. I mean, you can see it with the naked eye, and it takes up the full field of view in binoculars. So through the telescope, we're seeing bits and pieces of it, but we're going to zoom in onto Eta Carina itself. pretty much. You can kind of see it's got almost a bit like the Tarantula Nebula. It's almost divided into four. It's like a cross in the sky. But I was able to get some nice photos of it whilst I was in Namibia a few months ago, which I'll show you at some point. But we're going to go into here in this area, which is known as the Keyhole Nebula. Hopefully you'll see why through the photo. Otherwise, I did take a photo of it, say from Namibia, where I was under Portal 1 zero light pollution skies, which was spectacular.
Wow.
So I'll show you that one if all else fails. But yeah, so let me see if I can find this one now. Okay, called 192.
The star that this nebula is right next to, Eta Carina, is a fantastic star just in its own right. It glows about 5 million times as bright as the sun. So it is just a massive, massive star that's undergoing quite a bit of instability, potentially near the end of its life. Some of the most spectacular pictures I've ever seen of an individual star are of Eta Carina.
Yeah, I mean it's a monster of a thing. Again, I'm not sure whether you guys know this, but back in, I think it was 1843, it was actually the second brightest star in the entire sky. When it had what they called the Great Eruption, because there's actually two stars that are sort of locked in this gravitational embrace, and their stellar winds smash into each other, and the larger one of the two, I suppose the best word we can use, it kind of burst and threw off all of this energy which lit up the sky basically, and then it completely disappeared from view because of all that dust and gas that was created, and now it's gaining brightness again. I think I'm right in saying it's settled into a sort of about a 5-year cycle of variability in terms of its peak luminosity. But yeah, as you said, 4 or 5 million times as bright as the sun. It's insane.
Yeah, and the mental image you need to have is not of a bright point of light, but of these two enormous lobes of gas and dust that are being blown off in opposite directions by these central two stars. The Homunculus, I'm not sure if I'm pronouncing that right.
Homunculus.
Thank you, Ben. I just could not get it right there. Homunculus Nebula is just amazing.
Yeah, unfortunately, we can't get to the Homunculus Nebula. You'll be able to see Eta Carina, the star, but the Homunculus Nebula is what is surrounding the star itself. So you obviously need a pretty serious piece of kit for that. But this is actually coming out quite rather nicely. I think this has been the nicest picture we've got yet this evening. But it is such a bright object; it's very easy to get. As I said, we're only going to get a small piece of it, but you're going to see that area of Eta Carina itself, and then say what they call the Keyhole Nebula next to it. And actually, yeah, that's nice. Okay, share the screen. Sorry, I will do when I can't find you guys. There you are. Were you still looking at Stellarium then?
No, we've been just looking at each other and you.
Okay, well, there you go. Hopefully you can see that area now. So that's the Keyhole Nebula. You can see where
anybody else see it? I'm not. Okay.
Yeah, we can see it.
Oh, good.
You can see it. Oh, sorry, Sam. No offense. Not sure why it's
I got
alienated
it now.
you.
I needed to click on another button. We're good.
Okay, so we just open it up in Photoshop. You can see we've picked up some of that lovely pink from the hydrogen emissions. Obviously, this whole area, this massive area, is a big star-forming region. So it's the Orion Nebula on steroids, basically. It's the Orion Nebula's big brother, but an awful lot further away. In terms of size in the sky, it takes up about 4 times as much as the Orion Nebula. But the Orion Nebula is only 1,500 light years away. This is about 7,500 light years away. So it gives you an idea of just how bright it actually is. Or sometimes 8,500 light years across. The Orion Nebula from one side to the other is about 12 light years. This is thought to be around 450 to 500 light years from one side to the other. But remember, we're just looking at a small part of the whole thing.
And do you want to zoom in on just the center, the keyhole there, so we can just see that shape?
Yeah, sure.
The field of view. It's so cool.
Yeah,
You
it is.
really
It's
see
one of my
why it's
favorite
called
objects.
Keyhole Nebula.
And this is Eta Carina here. So you can see, even if you're perfectly focused, you won't get a nice sharp image on it, because if you've got that Homunculus Nebula, it's almost like an hourglass sort of coming out from those two stars, like two bubbles. They actually, I don't know, I'm sure you've seen it, but they've done those 3D printed models of it, so you can actually see what that nebula looks like. Incredible that we can do that. And you can see all these other little fibrous elements of dust and gas here, which is these Bok globules, as they're known, where baby stars are also being formed. So this giant area of hydrogen is being compressed, and you can see these little baby star clusters which are already forming. And there are some enormous stars in here. I wouldn't like to say where they are, but some of the brightest and hottest stars in our galaxy, I believe, are in the Carina Nebula in general. There's various open clusters in there. WR25 is apparently the most luminous star known, 6 million times brighter than the sun, somewhere in this this whole area. But yeah, so that is the famed Carina Nebula, and we're kind of all waiting. It's probably of all the stars in the sky, it's the one most likely to go supernova next. And it potentially may even be a hypernova rather than a supernova, which, again, Samuel, your astrophysics is probably better than mine, but I believe a hypernova is such a powerful thing that it doesn't leave anything behind. It's a complete obliteration. There's no neutron star or black hole left behind. It's just gone.
Yeah, that's my understanding as well. And I don't know if you zoomed in. We're just seeing that original image that you showed us.
If we keep doing this, eventually I'll get right. So when I click on it and it opens Photoshop, I forget I have to close it and then reshare the Photoshop screen. I'm very sorry.
Oh, there it is.
You know, we all got onto Zoom, whether it was for business or for sharing things like this. We all got into Zoom, but none of us ever got a Zoom class.
That's right.
Nobody taught us how to go share all these things. And
oh, that looks amazing right there, Ben. Wow.
I'm going to unmute myself to say, wow.
Very cool.
Yeah, no, that's an absolutely beautiful object. It really is one of the stars of the sky down here. So you can see, I can look up and clearly see the hazy patch of light. But yeah, so this was the open clusters that I was pointing out, and these little Bok globules that you can see forming these dense areas of dust and gas. And the Homunculus Nebula is in this blown out area somewhere. But yeah, it's a stunning arrangement, this, and so it's probably the prettiest part of the whole nebula. But just while you guys are appreciating that, let me just see if I can find you another photo of it in general.
And so those Bok globules that Ben was mentioning, those are examples of small areas of what are called dark nebulae. So the gas is actually obscuring starlight from behind it, which is why it looks dark. And probably one of the most well-known dark nebulae that we can see in the Northern Hemisphere is the one that makes up the Horsehead Nebula in the Orion constellation down below the main part of the Orion Nebula. And you get this incredible horsehead shape, but not nearly as complex as what we're seeing here.
No, the Horsehead, of course, is very faint as well. It's I've never been able to see it. I looked for it in Namibia. I could just make out the Flame Nebula, but I couldn't find the Horsehead through the telescope, at least.
Yeah,
so one day I'm going to photograph it, but
without a photograph.
Okay, I just want to stop that share and then share the picture of a screener I took out in Namibia. So this was with a star tracker. This is only at 200 millimeters, and it's not really cropped, just to give you an idea of how big it is. So it takes up a huge area of sky, and we are looking at, where are we? We're in here, there's Eta Carina there. So we're sort of looking at this little triangle here in the picture we just took. So we're sort of centered in on that area, but you can see the whole expanse of it. I mean, I haven't really captured everything, even at 200 millimeters only. But you can see these lovely dust lanes going through it, and it's kind of like split into a cross almost. But yeah, phenomenal, and just to see all the stars in that area.
Very cool.
just go back to again. Just out of interest, want to see if we can bring anything else out of it. You can see Photoshop again now.
Yes.
Yeah, good. I'm just going to keep checking with you, and then this removes that problem.
Excellent.
Contrast. Yeah, I mean, to be honest, I don't think there's much more I can do to it to make it stand out. But it's such an incredible object, and just with a, let's say, with a bog standard DSLR camera, which, if I'm honest, is 12 years old now and has been bumping around in Safari Land Rovers over some of the worst roads imaginable. It's never been serviced. It's not spec for astrophotography at all, and neither is this equipment particularly. But the simple fact that you can get a picture like that with amateur equipment is staggering, and that's one of the things that we'll go for. Exactly. I mean, it's not even stacked or anything, and I mean, thankfully, this Nikon, I think it's got a pretty good ISO capability. You can see I'm having a few issues with the focal reducer where the edges are being blown out. It's pretty focused in the center, but just with that focal reducer, I'm losing a bit of.
That's pretty typical.
Well, my field flattening is a bit of a problem, but I mean, I'm, as I said, blown away with what you can get with pretty amateurish equipment. Yeah, so that's a real showstopper, I think. That one. I keep saying that. Sorry, I've said that for about everything we've looked at, I think. Right, what else? Any other questions, or Sam, anything you want to add? Because I mean, it is such a famous area. I think we've sort of covered most of the information about it that I know of that we discussed. But again, unfortunately, I don't know anything in terms of the cultural side of it. There's nothing that I'm aware of here.
Nor am I.
All right, let's try for a galaxy.
Yeah, that's what I was going to suggest. That sounds great.
Yeah. We're going to try for Centaurus A, which is almost next door to, I'm back to Omega Centauri, but we're all in that same area of sky. Again, I don't want to undersell myself here, but please bear in mind that when we're starting to go after galaxies, this is where my equipment will fall short a little bit. We'll be able to make it out, but I don't think it's going to be, we're not going to get the level of detail we just got there, certainly. But to give you an idea of where we're going back to there's Omega Centauri, and here's the Centaurus A galaxy, also known as the Hamburger galaxy, which hopefully you'll be able to see why, because it looks like a big ball of light with a black line through the middle, just like a hamburger. But whilst you guys are doing that, let me just move the telescope and see what I can get.
So this is an elliptical, Ben?
Well, it's actually not sure where it falls in terms of its classification, because it's merging galaxies. It's a starburst galaxy. We think it was an elliptical galaxy that is in the process of swallowing a spiral galaxy.
Oh,
so cool. I'm not quite sure what that makes it in terms of designation.
Yeah, definitely one of the more photogenic galaxies out there, for reasons that we'll hopefully see with this gigantic dust lane that bisects the galaxy. Definitely what I think about when I think galaxy.
It's kind of like, I suppose it's similar to, you guys will have seen the Sombrero galaxy, I'm sure. It's not too dissimilar to that, except it's not quite as elongated as the Sombrero.
It's far more circular, right?
Bulbous, yeah.
Yeah.
But obviously we're stepping up in terms of distance now. I think, if I remember rightly, it's about 15 million light years away. But it is, I think it's the 5th brightest galaxy in the sky, actually.
Yeah, I mean, 15 million light years is really nothing for a galaxy when you think that the closest one is just under 3 million light years away.
Indeed, yeah. Well, I was lucky enough to get my first proper photos of the Andromeda Galaxy out there in Namibia. It's just, for us, it never gets very high on the horizon. I'm not sure what degrees, but not much more than sort of 25 degrees, I don't think. So we're a little bit limited in terms of what we can get photographically from here.
Yeah, it's pretty easy up here. I mean, it just crosses right over the top of the sky throughout the year. Right now, it's actually pretty close to the horizon during the evening. We don't get to see much of it for the next month or two, but then by June, it'll be back up again.
All right, well, we've got a little something there. I'm just gonna see, I'm learning now. I'm gonna open it in Photoshop and then share the screen with you.
All right.
But yeah, so as you say, we may not get we may not be able to see much of that, but as you've already seen, we've got some pretty spectacular other objects certainly that we can go after. Right, there you go. Hopefully you can see that. Let me just zoom in on it.
Mm-hmm.
Yeah, as I said, with the equipment we've got here, it's very difficult to get much into terms of detail, but you can clearly make out there that you've got this nice sort of bulbous sphere of light with this very obvious thick band running through it. So we think, yes, it was an elliptical galaxy which is in the process of swallowing what was a spiral galaxy here, and then that's obviously created a huge amount of star-forming activity within the galaxy, hence all the sort of glow from the center. But it's amazing to see just how much dust and gas is up there. I'm trying to remember its dimensions. So I've made all these notes, and they've got so scattered here that I'm struggling to find this one. But yeah, so you can see why it's called the Hamburger Galaxy, certainly. And you can actually pick it out. So even here where I'm in Bortle 5 skies, you can just see it in binoculars to give you an idea of how bright it actually is.
Other than the Magellanic Clouds, Ben, are there any naked eye galaxies that you can see in the southern hemisphere?
Not naked eye. There's a few you can pick up with binoculars. This one, and then the next one that we're going to have a look at, which is probably the prettier of the two, is the Southern Pinwheel Galaxy in Hydras, Hydra. So I think, can you see the Southern Pinwheel from where you are? It might be just above the horizon, but probably not really visible, I wouldn't think.
Yeah, I've actually I have seen it on maps. I've never tried to get it.
Yeah, I think it's going to be very low on your horizon there. So I'm just struggling. So my notes have gone flying all over the table now. So I'm just going to double check the specifics for you on Centaurus A. Right, yeah, so distance-wise, somewhere between 10 and 15 million light years away. Reckons about 60,000 light years across, yeah. So about half the size of the Milky Way. And let me just share this image with you, because this is a serious Hubble image of it, and you can see what it really looks like close up. So now you can clearly see that bulge, and you can see this beautiful arm wrapping around it, and the distortion that has occurred by all the spinning and these jets being blown off from the center of the galaxy. So I mean, it's a stunning object. It's just a little out of reach of what we've got here, but you can certainly see the general shape in the photo we got this evening.
And those jets aren't optical wavelengths. Those are a combination of radio and X-rays. So with a lot of these big elliptical galaxies that have supermassive black holes in the center of them, these radio and X-ray jets are emanating from just beyond the event horizon of the black hole. We don't even totally know how they're formed. Something about the strong magnetic fields of black holes, but they somehow collimate very, very hot gas and dust, and then shoot that away perpendicularly from the black hole in two different directions. And so they make these really enigmatic jets that can stream, several million light years away from the galaxy itself.
Yeah, fifth brightest galaxy in the sky. I'm just trying to find any other sort of really poignant information other than just sort of quoting things. I'm just trying to find a ballpark how many stars are in there. I think it's at least 100 billion. Just trying to see if we've got a figure. I can't find anything quickly, so I don't want to sit here and read. And whilst you guys are doing nothing. Anyway.
Yeah, I'm not sure
Right,
either.
so
Actually.
that's,
I just tried to do a quick search for it and nothing came up. It may be one of these
No, I couldn't find
galaxies
it.
that we just don't know that figure because it's obscured by so much dust.
Well, yes, I think that's probably a good point. You can see just how much is actually there. Do anything else with it? I think really say with what I've got, I need to take multiple images and stack them to get any more detail. But I'm glad that we can clearly see that that thick line running through it, which is obviously its most obvious characteristic. What we can do now, though, is try for M83 the Southern Pinwheel, because that's got a beautiful sort of classic spiral shape. It's very similar to your Northern Pinwheel galaxy. It's a little bit more condensed. The arms are not quite so spread out in the Southern Pinwheel. But hopefully we'll at least be able to see the general shape of it. Again, this is where, having watched your last virtual stargazing, so I start to get telescope envy when we start doing galaxies.
I'll just wait till we get the 1 meter set up on the summit of Snow King, then we're going to make lots of
that's when I'm coming that side. So, telescope's just making some funny noises. I'm just checking up on her. But you should have heard what it sounded like when I came back from Namibia, because the air was so dry there and dusty. And it was basically it was used pretty much every night for 6 weeks, which is more than it's used to, that's for sure. So struggling to find it. Just wake it up again. And then after this, I mean, there's a couple of other objects that we could do in the southern sky, but I think we've covered most of the ones really that I think we can appreciate in the telescope here. But as I said here, we've got things like Scorpio and Sagittarius are now beginning to rise. Scorpio is actually quite high above my head now. So I asked you earlier, Sam, I know you guys can see it, but how well can you see objects like M4, the globular cluster there by Antares, and can you see the butterfly cluster from where you are?
We can, yeah, we can actually see all those in mid-August.
Oh, you can see. I was trying to work out from just looking at Stellarium there how high they got in the sky, and I wasn't sure whether the butterfly cluster would be high enough for you guys to see it properly.
Yeah, they're not very high. They're within 10 or 15 degrees of the horizon. But even seeing a fuzzy version of a lot of those objects is worth it because they're so incredible. Yeah, if you wanted to go to M16, I wouldn't be upset.
Yeah, well, I was going to suggest I wanted to do M4 because it would sort of be a nice comparison to Omega Centauri, and then we've got a choice. The others, things like M8 and M20, should be high enough to get a decent photograph off, I think, but we can certainly try for the butterfly cluster.
Great.
Okay,
I've got a picture of M16 right in front of me and a picture of M8 right behind me, so it'll be fun to see those in real time.
Okay, I've got some. I'm going to share the screen with you. I've got some pretty bad field rotation on the photo, but it's almost at the zenith now. It's almost directly above me, and so therefore I'm really picking up that field rotation. But the center part where the galaxy is, thankfully, seems to be okay. Just need to find the share button again. Okay, so we'll do the Photoshop thing with it and just bring out some of the detail, but you can clearly see we've got a nice bar running through the nucleus of the galaxy there, and you can see these nice spiral arms, which we'll hopefully bring out in a second. So it looks very a bit like a mixture between your northern pinwheel and Bode's galaxy, I suppose. It's sort of somewhere in between the two, I guess.
Yeah. Well, yeah, that field rotation is pretty remarkable.
Well, that's the benefits. So I'm just opening Photoshop again. That's the pitfalls of not having an equatorial mount, unfortunately. But say, hopefully next time we do this, I will have one.
Yeah.
But yeah, it seems to be particularly accentuated. We haven't seen that on the previous images, so I'm not quite sure why.
We get exactly the same thing with our 11-inch Celestrons, and we're pointing at stuff straight above our heads. That's when the alt-as mounts really don't work very well.
Okay, it should just be opening. Okay, we'll ignore the nice, pretty swirls around the outside.
Oh yeah, there you go. We can see that.
Detail.
Yeah, that's pretty good.
Getting there. You can actually even see a little bit of the pinks coming out from these little star-forming regions in the arms there.
Yeah.
Sure, what else I can do again to make it stand out.
Yeah, that looks okay, actually. I mean, we can clearly see the swoosh of the spiral arms there.
The swoosh, I like that. Yeah.
Yeah.
One more.
Oh yeah, that right there is pretty good, actually.
Yeah, even if we blow it out a little bit.
Yeah, I mean, it blows out the center, but then we can really see the shape nicely.
It's not beautiful, but yeah, you can clearly see the bulge and then the bar running through it, and you can see we've just caught a little bit of the arms coming right the way out to here, and this one coming out, but it's very circular. But it's nicely proportioned. It's a very pretty one, and you can see what I like about this one is in terms of telescopic viewing, and when we do outreach evenings and things, to show people a galaxy is often quite difficult, but under the nice dark skies in the Kruger way, we're operating under Portal 2, Portal 3 skies, you can clearly see the structure of the arms, which is really nice to be able to actually see through the telescope. I've never looked at the Northern Hemisphere's pinwheel galaxy through a telescope. I'm not sure how much detail you would get there with a 10-inch under dark skies.
Yeah, even with the 20-inch, you don't get much in the pinwheel. However, with the Whirlpool galaxy, you do. M51.
Okay, yes, you've got both of those. That's Ursa. Is that Ursa Major or is that Cassiopeia? I'm trying to remember where that one is.
Yeah.
It is Ursa Major, yeah.
Yeah.
Problem is, when I was back in the UK doing this, I never had the equipment to actually look for anything like that.
Yeah, it's that one's it's much more compact than our pinwheel galaxy. And so I think even when you take an image, the pinwheel is a bit more enigmatic. When you're just looking actually through the telescope without a camera, seeing M51 is a little more eye-popping.
I'm just going to try, I'm worried if we try a longer shutter speed that obviously with that field rotation, it might mess up the middle as well. But I'm just going to try a 30-second exposure. That was only 20 seconds. I'm just going to try a 30 and see what we can get. And for interest's sake, I'll put it up to ISO 5000 as well. Again, so it doesn't matter if we've got a bit of noise there, obviously, as long as you guys can see the structure.
I think this is the most distant object we've looked at so far, right?
It is, yes. I'm desperately trying to. So I really apologize. All my notes are strewn over the table, and I can't find any of the stuff I've written down to remind myself how far away it is. I did have all those facts and figures, but I think under the stresses of live entertainment, I'm falling apart.
I think this one it's just a little bit farther than the last one we looked at. I think this one is just over 15 million light years.
I think it sounds about right, 16 maybe.
Yeah, something like that.
Right. Let's see. Okay, so there we go. So that's a 30-second at 5,000 short. We've got a proper vortex going on. But yeah, we've got a bit more detail in the arms there.
Yeah, we can't see it yet. Ben.
What are you seeing at the moment?
Oh, sorry. I needed to click. No, I don't think we can see it unless somebody else can.
You should be able to see it now.
Oh yeah, here it comes. Yeah, a little more detail there.
Yeah, so this I pushed up the ISO to 5,000 and took 30 seconds. We seem to have got away with that. I've got it slap bang in the center of the vortex, even though it doesn't look like it is in the center. It's the most minimum amount of rotation where it is stuck in. Which I quite like the photo as is.
Yeah,
with all those
nice.
the swirls, it gives it a nice depth. Bring any more of that out.
Yeah, that's lovely.
Get a little bit more there. As a quick edit, that I think is as good as we're going to do with just
that's pretty
the
good.
single image. But yeah, I think that looks nice. So yeah, there we go. I'll leave it at that. Right, let me see if I can just find, because I did find out, actually, I did a little talk and we looked at it whilst I was doing the training the other day, but I've done so much of them over the last couple of days that they've kind of all blurred into one, and I cannot confidently separate them as to exactly all the information on each one. But you can see lots of star forming regions happening in there.
Yeah, all those little brighter specks that you can see within the spiral structure, those are the star forming regions that Ben was just talking about. So each of those is a huge cloud of gas, ranging from 10 to a couple hundred times the size of the solar system. And those gas clouds are becoming so hot and so dense in some areas that nuclear fusion is beginning, and that's the core of a star that'll eventually be born out of that nebula. All the gas will be absorbed over the course of several millions of years, perhaps even billions of years, and then we'll end up with an open cluster, like those two that we saw at the very beginning this afternoon.
Yeah, so just in terms of size, it's very similar to the Centaurus A galaxy that we just looked at. You're quite right, they say about 15.5 million light years away. And it's also about 55 or 60,000 light years across. Interestingly, I didn't actually realize this, it was the first galaxy to be discovered outside the local group and the third of all galaxies to be located, the third of all galaxies after Andromeda and M32, apparently.
Nice. So the local group that Ben just mentioned are the group of, I think, about a dozen or so galaxies that the Milky Way is gravitationally bound to. And we're all together moving through the universe. Some of those galaxies that we're actually on a collision course with right now, including Andromeda, the largest member of the local group. That merger happens in about 3.5 billion years from now. But eventually, the belief is that all the galaxies in the local group will merge together some 100 billion years from now.
So I've just remembered what the particularly interesting thing was about this galaxy we were discussing the other day. Sorry to interrupt you there, Samuel, but we've discovered it within the last 100 years. We've discovered or visibly seen over 6 supernova explosions, which is an awful lot for a galaxy. As far as I know, we average 1 per galaxy per 100 years, and for this one to have 6 is the second most, I think, that we've ever recorded. There was one that had 9. I just can't remember which one it actually was. But all that being attributed to the fact that you've got all that star formation, you've got all that dust and gas that we can clearly see here, which is obviously making very, very large stars, which are running through their life very, very quickly, and creating an awful lot of supernova activity, which I assume is then going to spur on more supernova activity with all the accompanying shock waves and gravitational disturbance from it as well. Also discovered by de la Caille, the French guy, from his observatory in South Africa in the 1780s as well. So he was very busy whilst he was down here.
Sounds
Just trying
like
to see if I can get an idea of how many stars are in there. 40 billion, they reckon, in terms of stars.
Yeah, so quite a bit smaller than the Milky Way, 10 times smaller perhaps. I think the current estimate is that we have about 400 billion in the Milky Way.
Here's a lovely image, a proper European Space Agency image. So in here, you can clearly, hopefully you can see that. You can clearly see all of these areas of star formation. Over 3,000 star clusters that we're aware of that we found in these spiral arms.
Looks like there's some background galaxies on the left-hand side as well.
Yeah, very, very probably.
Yeah.
I'll have to have a look and see what those are. But there you can see a beautiful close-up, all these star-forming regions, all this ionized hydrogen glowing pink, and the blue will be the reflection nebula, reflecting the light from the stars as opposed to the hydrogen within it actually giving off the energy. Yeah, some stunning photographs of it. Yeah, very, very beautiful objects. One of my favorites. So I have tried to, last year I did try and snap a couple of photos of it and actually stack them together, and it didn't come out too badly. That was my first attempt, but it's going to be one of those targets. If I can get that equatorial mount in the next couple of weeks, this will be one of the first things I'm going to give a crack to, because obviously the structure is so nice. It's the only face-on spiral galaxy, I think, that is sort of within reach here. Really, with what I've got here, you're looking at the Sombrero Galaxy, Centaurus A, this one, and obviously I can look at the Magellanic Clouds and individual features of them. But for a nice face-on spiral galaxy, this is our best one, I think.
Nice.
Right. What should we go for next? Should you want to try for? Sorry, go on.
Yeah, I was going to say let's move over to Scorpio and do some of those objects.
Yeah, let's try for M4.
Sounds good. So M4 is another globular cluster that will definitely lack some luster compared to Omega Centauri.
Yeah, well, I thought it'd be a nice comparison between the two.
Yeah, M4 is more akin to what we get here with the Hercules globular cluster, although I think the Hercules globular is quite a bit brighter than M4.
Yeah, I think so. The thing about M4 is that it's relatively close. That's what makes M4 special. It's one of the closest globulars, whereas the other ones that we're looking at tend to be tens of thousands of light years away. This one is only 7,000 light years away. So it's one of the most studied globular clusters there, because yes, it's not the biggest one in the world. I think it only contains around about 20 or 30,000 stars versus the 10 million stars that we were just looking at. But take remember the Omega Centauri being a galactic core, very probably a slightly different kettle of fish, as they say. And it's one of the oldest. Certainly, it's been dated at over 13 billion years old. So it contains some of the oldest stars that we know of. And then probably the thing I like about it particularly is what we call the planet. I forget what it's called. It was named after a biblical character, Methuselah or something along those lines. But also known as the Genesis planet.
Yep.
Yeah, which was the first circumbinary star or circumbinary planet that we found. So if I remember rightly, it's orbiting a white dwarf and a pulsar, and orbiting the two of them. And it's the first one like that we've found.
And the age of sorry, go ahead, Ben.
No. So I'm just saying, I've just taken the photo there. It certainly does lack a little bit of the oomph that we had with Omega Centauri, but it's a good comparison to show off Omega Centauri again.
Nice.
It's coming. I haven't shared the screen
yet. Ben was mentioning the age of these globular clusters at 12 or 13 billion years old. So that's the age of the cluster, and also the age of the stars within the cluster. So what that means is that these stars are, for the most part, stars that are the original stars to form after the Big Bang. So they're they're first generation stars, and so they lack all of the heavy elements necessary to form planets. such as our sun and younger stars have that are, being born from the leftover remains of a previous generation of stars that formed those heavy elements and then exploded outwards. But these stars are what we call metal poor stars, mostly just hydrogen, helium, maybe some oxygen and carbon in their cores, but that's about it. No heavy stuff, like the rocky materials necessary to form planets.
So they have found, so they did find this one planet there. So I actually wanted to ask you about, or anybody else there about that, how they thought that planet might have formed, because yes, by definition, if they're 13 billion years old, I mean, there should have been very little heavy elemental material there for it to be created. But
Yeah,
but
well,
you
there are
seem to
always
think that it's
exceptions.
there. So, yeah.
Yeah,
I
I
wondered if
don't
there
think
was
it's
any
well
sort of
understood.
mechanism.
There, what must have happened is that there must have been some truly huge stars within the cluster that have since exploded, creating all the heavy elements. And then, that could have happened relatively quickly if the stars were large enough, as some of the early stars were in the early universe. That the whole lifespan of those, very, very large early stars might have just been several 100,000 years, or even just a few million years. So there's time for that to have happened, and then a second generation of stars to have formed with heavy materials to form planets. But that seems to be the exception as opposed to the norm in globular clusters. But as Ben pointed out, there's a really famous one in here.
Yeah, I believe it's the oldest known exoplanet that we're aware of. So that, yeah, around about 13 billion years old. But you can see it there. I think that's good. I think I might be losing a little bit of focus, but I'm just nervous to fiddle around with it too much. But you can see, whereas Omega Centauri took up, pretty much 2/3 of the field of view that we were looking at. This is a much more loosely clustered, and so only around about 20,000 individual stars there, as opposed to potentially as many as 10 million. Let me just find you a proper photograph of it as well, so you can see it in all of its Hubble glory. Or right here. Okay, let me just share the screen with you. Okay, so hopefully you can see that one now. So that's another European Space Agency image, but you can see, compared to Omega Centauri, nothing like the structure and the amount of stars in there, but still a beautiful object nonetheless. And I think it's one that a lot of people know because it's so easy to find. You can see it's slap bang next door to Antares and Scorpius. If you guys have never seen it, just point a pair of binoculars at Scorpius on a dark night and you'll see it clearly. For me, it's above Antares at the moment. So.
There's so much in that part of the sky. It's a lot of fun, either to use a pair of binoculars or just to take the telescope manually and just move it around in that area. Globular clusters and nebulae and open clusters. It's a lot of fun just to kind of plunge around there at night.
Definitely. It's this whole area of sky there, even with a pair of binoculars, is stunning. Yeah. Right. I'm just going to see if we can do a quick shot of the Lagoon Nebula as well, since we're here. Messier 8. Which is the only other star-forming region visible to the naked eye. Just going to take the risk of fiddling with the focus touch. Sorry, Sammy, you were saying?
Yeah, I was going to say, for those of us in the Northern Hemisphere, this area of the sky that we're talking about, the reason that it's so rich in all of these objects is that from our perspective, it's aligned with the disk of the Milky Way. So in the summertime, when you see that really bright band of light through the summer sky, you're looking in towards the center of the Milky Way galaxy along the plane of the galaxy. That's why it's thick there. That's why it's the brightest there. There's just so many stars and other objects. And then when you look right in towards Scorpio and Sagittarius next to it, you really are looking in towards the core of the Milky Way, its center. And there's just a lot between us and the core that just lines up along our line of sight. So that's why it's a
Yeah,
really
'cause
prominent part of the sky to look at.
hopefully you guys can see Stellarium now. So I'm just showing you where
Yeah.
we were. So if anyone doesn't know what M4 is, they're right next to Centaurus. So here is the Scorpion. Let me just put the art on and you can visualize it a little bit better. But here's the Scorpion. So we just looked at here, and now we're going to go to M8, which is in here somewhere, one of these ones somewhere.
Yeah. So Antares, the name of that is interesting and similar to what you were mentioning before, Ben, about the constellation that was not Crux. Antares means not Mars, and it was named that for similar reasons. People were confusing it with Mars, and so it was named Antares, not Mars, to hopefully alleviate some of that confusion. But it has a similar brightness and a similar reddish glow in the sky that Mars has. And that's why there was some confusion. But Antares is a red supergiant, similar to Betelgeuse and that star we saw in the original open cluster that Ben showed us at the very beginning.
Yeah, so we actually know down here is whether it's just sort of a translation thing, is the rival of Mars, with the story being that, it was deemed that how dare this star be the same color and similar brightness to Mars, and with it being very close to the ecliptic, they do occasionally come very close to one another, as yes, the rival of Mars.
Yeah.
Okay, so here's the Lagoon Nebula. Yeah, can you guys? No, I haven't shared the screen yet. At least we're figuring it out as we go.
Yeah.
Yeah, I've definitely lost a little bit of focus. Sorry, guys, but you should be able to see clearly the crux of what we're looking at. So here is the Lagoon Nebula, massive area of star formation again, and you can see what makes it the Lagoon Nebula with this black sort of stripe of gas running through it, and also other Bok globules and things that we can see in there. Just fiddle with the focus in a moment. See if we can fix that.
Yeah, that's pretty lovely.
Yeah, it's another nice, easy one. Again, easily visible with the naked eye. Again, from where I sit, I can pick it out the sky, no problem on a dark moonless night like tonight. Yeah, and obviously the pink again from all that ionized hydrogen, and it's a lovely object to look at through the telescope. You can see that detail very nicely. You can clearly see the lagoon running through it on the scope.
Yeah, the image of it that I have behind me has about 60 hours of exposure time. And so the detail is pretty exquisite, but this is not bad for 20 seconds.
No, exactly. And so you can clearly see the color there. Yeah, it's got a bit of bloating going on, but the whole point was to show you the dark patch, which is where the name comes from, why it is called the Lagoon. Yeah, and that's about 5,000 light years away. So again, much further away than the Orion Nebula. And to give you an idea of sort of dimensions, from one side to the other is about 140 and it's by about 60 light years across. And yeah, lots of these on a more detailed image like you've got there. You'll be able to see all of those little knots of gas, and again those little Bok globules there. And then this very bright area, obviously we've blown it out. So if we took a shorter exposure, there's another little nebula in here known as the Hourglass Nebula. It looked very similar to that sort of Homunculus Nebula we were talking about with two sort of lobes. You might be able to just see the basis of it again. So you may not have lost it, but you can maybe just see here and here there's two lobes of light, which
barely.
is, I wonder if we've got it. In fact, that's better. If I take those off, you can see it there. Here and here, you can kind of see the hourglass shape just to the underside of the star. So they call that the Hourglass Nebula. There's another Hourglass Nebula in the constellation of Musca Fly, but obviously this is a different one. That's a planetary nebula, if I remember rightly.
I was just going to ask whether that's planetary, and that's typically what I think about when I'm like thinking about the hourglass shape of nebula. You know, we've got the Dumbbell Nebula up here that displays that really nicely.
Yeah, so this is a lovely one.
Yeah, so planetary nebula, even though we didn't get a great look at that one, they're a different type of nebula from what we've looked at so far. Planetary nebulae are the leftover stuff from sun-like stars. So unlike these gigantic star-forming regions that are like, 30, 40, 50, 60 times the size of the entire solar system, where hundreds or even thousands of stars form, a planetary nebula is basically the corpse of a sun-like star that has run out of fuel and cast its outer layers off into space. It does that symmetrically through the poles of the star, and the gas expands as it goes outwards. And so you end up with these really lovely hourglass shapes, depending on the orientation from which you see them. So the Dumbbell Nebula in the Northern Hemisphere is a great example that we see edge on of these two expanding lobes of gas rather. Whereas the Ring Nebula, which is the same type of object, is oriented with respect to us that we look down through one end of the hourglass. And so we just see a bright ring.
Just since you mentioned it, we haven't tried the Planetary Nebula yet. I mean, there's a very small object in comparison to the other things that we have been looking at, but there is quite a bright one in Centaurus, which is called the Blue Planetary Nebula, which you can certainly see clearly through a telescope. It's still going to be quite small, and I wonder with the focal reducer what we're going to pick up. I'd rather not start playing around and changing things up there.
Yeah, we don't need to do that.
Do some irreparable damage the way it's been going this evening. Yeah. But I thought we'll just try and see what we get. So you heard the telescope moving then, so I'm just do that, and I'm just going to see if we can get anything off that at all.
Yeah, so our sun and stars like our sun don't end their existence spectacularly like supernovae do. Stars that do that have to be at least 5 times the mass of the sun. Stars like our sun really just die with a whimper, but still produce beautiful remains for us to see, thousands or even hundreds of thousands or millions of years later, as the core of the star continues to cool off and illuminates the gas around it.
Yeah, actually, over the last couple of days, I looked at 2 planetary nebulas, which I hadn't looked at before. So we looked at the Blue Planetary Nebula last night, and then also the Ghost of Jupiter, which is another one in Hydras as well, which looks very similar through the telescope with a sort of obvious blue ball, obviously named after, because it looks very similar in terms of size to Jupiter when you see it.
Yeah, we've got one called the Blue Snowball.
Oh, well, yeah, so it's probably very similar.
Mm-hmm.
Yeah, I can just make it out there, but to be honest, everything I've lost so much focus. I think I'm going to have to. I'm just going to disappear for 2 minutes. I just need to put my Baton-off mask back on, and I just want to adjust the focus because it seems to have deteriorated. I tried to fix it, and obviously I've made it worse. So I just want to quickly fix that. I'll be back in a minute, probably 2 minutes.
Yeah,
maybe.
Sounds good, Ben.
And then I think from there we can do the Eagle Nebula, and then I don't know. I think maybe from there we'll take any requests. I think is probably the easiest thing. I mean, there's lots of other stuff. There's the Trifid we can do, but I know the point of this was to show you stuff that you couldn't see from where you are. So if there is anything else that people have heard of or know about in the Southern Hemisphere that I haven't mentioned, by all means, let me know. But yeah, I'm just going to sort out the focus. I'll be back in a sec.
That sounds great. So this Baton-off mask that Ben is using to focus his telescope, it's this. I wish I had one sitting here. I've got one at the office. It's just this plastic ring as big as the aperture of his telescope, so it's about 10 inches in diameter. And you slip this plastic ring out in front of the telescope, and it has all these stripes of plastic and then gaps between each stripe, and they're arranged in a very certain way so that when you take a picture through this mask, it creates these diffraction patterns. And if you have your focus just right on your telescope, the diffraction patterns line up to give you these perfectly parallel lines. And so it's a really easy way to get the focus just right when you're doing imaging. Otherwise, you just take a picture and you make a tiny little adjustment, you take another picture, and you keep doing that ad nauseum. The Baton-off mask makes it a much, much quicker process. And we use the same thing here when we're trying to do astrophotography with our telescopes. And sometimes it's a quick process and sometimes not. we'll see how it goes. But as Ben is working on that, is there anybody who knows of any southern hemisphere objects that they've either heard of or have read about or seen pictures of that they'd like Ben to try to photograph?
Not I.
I will ask Ben to show us a picture of the great emu of the southern hemisphere. It's an area of the sky that has a large dark nebula through it, and kind of outlines the shape of an emu. It's not something you can photograph because it's huge, but I think he's got a picture of it that he just took with his camera that he showed last time. So it's kind of cool. So I'll have him show that one to us, but maybe we'll end with the Eagle Nebula. And it's kind of a cool place to end because one part of the Eagle Nebula is known as the Pillars of Creation. Probably one of the most famous Hubble Space Telescope pictures ever taken. These pillars extend for about a dozen light years long. And on the very tips of these pillars, you can see new stars forming. But it's an amazing image to think about the vastness of the universe and how the process of stellar evolution leads to the formation of all the heavy elements in the universe that end up forming sun-like stars with collections of planets around them, and eventually stuff like us that can actually talk about the process that formed us. And so I think Carl Sagan actually said that much more eloquently than I just did, in which he said, we are the universe knowing itself. So the pillars of creation are a great way to capture that idea. So yeah, once Ben gets back, we'll take a look at the Eagle Nebula and the pillars of creation, and then we can wrap things up. And if there are any questions about any of the stuff that we've looked at before, feel free to ask those as well, whether it be about galaxies or the emission nebulae, stars, etc. that we've seen.
Right, sorry about that. I have returned. Yeah,
Right.
fix the focus. I'm just slewing to M16 now for you guys. I did manage to get a quick shot of that blue planetary nebula, which you can just about see there. But to be honest, it just looks like a big blue star.
Oh, yeah.
But you can clearly see it's larger blue. It's definitely there. That's the main thing. So at least you can say you've looked at a planetary nebula now. So I'm sure you've given everybody the quick lowdown. But yeah, something like our sun that is gently bleeding its atmosphere off into space. And
Yeah, that's exactly what
the blue color comes from. It's doubly ionized oxygen, isn't it? The blue haze that we're picking up. Is it ionized oxygen? It's the oxygen, isn't it, that we get to see?
I
Because
believe
of that
so,
blue
yeah.
color. Yeah.
Mm-hmm.
Okay. So that was there. So right. So let's see what happens with M16. I just came back then and heard you give your little talk about it. But yeah, I mean, I have photographed it once before, but that was before I knew that it made a difference in terms of you had to get your spacing correct, especially if you're using a focal reducer. So I'm not exactly chuffed with the one that I've got. Well, you can see them, so I suppose I can't really complain. But yeah, I'm very keen to give this one another crack. Sure. Just looking at the screen, it's jumping around. I think you're having the occasional tracking issue. I think that's why some of them are coming out a little blurry at times. For some reason, until I can hear it click. Right, we have a proper technical problem now. My telescope has just decided to reset itself, which means we've lost all alignment. So it's really up to you, Samuel, because it's going to take me probably 5 or 7 minutes to get it going again. How much you want to see M16, or whether you want to leave it at that. Say the word and I can press the button, but it's going to have to run through its whole cycle to align itself again. I don't know what happened there. Sorry, it just went dead.
I don't think worry about that. I've I think I have a really lovely image of M16
But whilst
that,
you're finding that, let me find my image of
oh yeah,
M16, and then I'll show my one, and then you can show yours, and that will really give yours a bit more of a punch as well.
sounds
There you go.
great.
Bear in mind, this was taken with, I think this was a stack of only about, I think it was only like 20, 30-second images, I think. So I'm sure the one you're going to show us is a little more advanced than that. But here you go. But there you can clearly see the those pillars of creation which showed up there. I'm not sure how much information you gave there, Samuel, but obviously just in terms of scale, so from the base of that tip of that finger to the top is about 4 light years. So that's the same distance between us and Alpha Centauri, our closest star. You can see this massive area and all these little baby stars being formed in here, slowly blasting away the dust and gas. And I heard you're the last bit you were saying there about Carl Sagan, and yeah, some of his phrases are fantastic. We're all made of star stuff, etc., etc. But yeah, all those elements being created in here, or I should say, within the cores of those stars, and then creating all those next generations of stars. But yeah, it is a really spectacular feature of space, this one.
So I'll, Ben, if you want to unshare, I'll
Yeah,
share
let me stop that.
my screen.
I'll
So
look the other way.
And I can't claim any credit for this image that I'm about to show you. This was taken by Mike Adler, one of our board members who has the large telescope that we were talking about earlier. And I think this image I'm about to show you represents over 100 hours of exposure time. So there you go. And here are those pillars of creation that we were just talking about. It's a flip. It's reversed from what Ben just showed us. But there you go. And on the, I'll zoom in here a little bit and.
Sorry, I just shut my dog up. Hold on.
Yeah, the very tips of these regions here are where young stars are being formed. And then you can see that the pillars of creation are just one small part of a much, much larger complex of dust and gas that's all collectively known as the Eagle Nebula. I believe this is like the eagle's head right here and the outstretched wings. But for kicks, Mike Adler compared the image of the pillars of creation that we see here with that of the Hubble Space Telescope. So let me show you the comparison image here. There you go. So the larger one on the left is what Mike Adler took with his 20-inch telescope from Jackson, Wyoming. And the inset on the right is what the Hubble Space Telescope got from orbit around the Earth. So obviously a lot more detail, a sharper image, but not bad for a ground-based comparison from Jackson.
Yeah, it's amazing what you can get with. I wouldn't call that amateur equipment at all, but what somebody can do from here. Yes, who isn't working in a full-blooded observatory. It's amazing with the technology. I'm sure it's just getting better. I see that a few months ago they released the new ZWO, the 2600 Pro or something, which is going to replace the 1600.
Yeah.
So I'm looking forward to seeing what that can do. Problem is, you keep saving up to buy one of these things, and then technology moves so quickly that a few months later, I mean, there's a new one again.
Yeah, and NASA has the same problem when they take several decades to build a space telescope and then launch it, literally with decades old electronics and instrumentation on it, but no way around it.
It'll be interesting if they are still planning on launching James Webb this year, because last I heard it's still certainly a possibility for this year. I wonder, it'd be interesting to see what they get if they try and recreate this. I know it's only seeing in infrared, but to combine all of the footage would make it an incredible image.
It should be pretty awesome in infrared. Yeah. As far as I know, James Webb is still scheduled to be launched in October. I just got an email from a NASA rep who is trying to get organizations like Wyoming Stargazing to do launch parties for the James Webb. So I think we'll try to do a launch party in October when that happens. So.
Might try and do the same. Yeah.
Yeah, there you go.
Organize something, because of course the next big thing we've got, well, we'll all enjoy that, of course, is the lunar eclipse next month.
That's right.
Yeah, 26th of May. So we're also looking forward to that. I actually was chatting to the lodge where I was just at this morning. We're talking about maybe putting on an event. For that. So let's see.
Nice.
But yeah, so very sorry for all of the technical problems we've had. But yeah, my telescope has decided that I think that was it for this evening. I don't know what it was doing, it was jumping around and then suddenly just reset itself. So very sorry about that. But yeah, in terms of the other stuff, I hope you enjoyed some of those jewels of the southern skies. As I said, we really have some beautiful objects down here. The jewel box is stunning visually. Mega Centurion is something else, and you saw the clarity and the richness of Eta Carina there as well as another example. So yeah, I hope you've enjoyed it and hope you've enjoyed some of the images and given you a good idea of what we get to see out here on a nightly basis, especially now we're coming into winter. We don't really expect to see another cloud in the sky for the next 6 months. So winter here is cold and dry. So it's ideal conditions now for astronomy. So very much looking forward to Milky Way season, and we get the arm of the Milky Way goes almost directly overhead. So we're very spoiled down here for those objects in Sagittarius and Scorpius and the like.
Nice. Well, Ben, thank you so much for your time and sharing the southern night sky with us. We really appreciate it. And yeah, we'll definitely find time to do this again sometime in the next few dry, clear months that you've got down there.
Let's hope, yeah, and hopefully the next time we do this, I'll have the equatorial mount in hand. I'm not sure what the learning curve is going to be. There might be some expletives. You might have to bleep me out if I'm using it for the first time, but we'll try and give it a few runs for its money. And even if I can't get myself a decent camera, I've actually got I was chatting to someone today, it just was a little bit too late notice, but I've got somebody who's got a full frame sensor camera who said I could borrow it in theory as well. So if I can get that next time as well, we get a little bit of better resolution and more megapixels and see what else we can do. But yeah, thanks again, everybody. Unless there's any other questions about anything else, I think, yeah, I guess I'll hand it back over to you. But thanks very much for asking me to do it, and thanks for joining us.
And thanks very much. A wonderful presentation. You have nothing to apologize for.
So I'm always like that, but yeah, when I watched your guys' virtual stargazing, I didn't realize it was a 20-inch telescope that I'm competing against. But as I said, all joking aside, I'm mind blown with what I can get with the equipment that I've got, and it's whetted my appetite for more. And my poor long-suffering wife, I'm going to have to justify it to her where all this money is going to go soon to keep buying better and better equipment. But I think the bug bit quite a while ago, and it's here to stay.
Oh, Ben, thanks. You did a wonderful job, and it's so nice to be able to just see the southern sky. I mean, you have to think how unique that is for us, and I'd really like to see it.
No, you're most welcome. So if you guys ever do come down this way, if you ever fancy a safari or something, you must give us a shout, and we'll meet up, and I'll give you a full-blooded tour.
Oh, I'm going to take you up on that someday, Ben.
Do.
All right. Well, thanks everybody for being here. It's been a lot of fun, and enjoy the rest of your Sunday, and we'll see you next time.
Thank you, Sam.
Yeah, you're welcome.
Cheers, everybody.
See you, Ben. Thanks again.
Bye.
Thanks for being here, everyone.
Bye.
Pleasure.
Bye.